Okay, early morning hustle. I don't know if I said that in those past videos, but this is 2026 finally. So we're gonna do one way ANOVA with this lab. So go ahead and click on this button. It's going to allow me to download it, and it's gonna then show up in my downloads folder. It's there already twice. That was a mistake. Don't be confused by that. I'm just going to select the previous one. The same thing. All right, so this is lab 3. So if you're watching this and you're doing this, we're going to work with some McDonald's data. Open with RStudio. Okay, by default. Oh, because it's already open. That's why. There we go. All right. So one way ANOVA with McDonald's data. Okay. I thought for the longest time I stopped going to McDonald's, and I was like, oh, I'm not gonna go there anymore. And then the fries, I had some fries recently. They're pretty good, but it's not commercial. So go ahead and let's do this. So one way ANOVA McDonald's menu items in terms of calories. So you can imagine if you are intern at McDonald's and you want to figure out how did they, how are the calories differ from different categories. That could be a legitimate question. And so the lab examines the calorie count across McDonald's menu categories. Our goal is to determine whether the average or the mean calorie count differs across the various food and beverage categories on the McDonald's menu. More information about the McDonald's data set. I found this a couple of years back. So if I run this now, okay, that's cool. You don't let's say, see that we have the McDonald's data. But if you run this should work. Yeah, you should now see the McDonald's data. Okay, so now you have this, data set. So you have the categories, that's one element, and then you have the calories. So all these other variables are nice and cool, but we're not going to use them. But the thing is, one more thing. When it comes to these calories, there are so many different categories. There's too many categories. And so a little technique that you would learn in Stat 331 is to group these calories according to maybe another specification. So you can say beef and pork, breakfast and chicken and fish are meals, whereas coffee and tea are just hot drinks. So that's what we can, reclassify these categories. And that's what we do here. So I reclassify the categories in terms of the data, in terms of our data, to be able to, I did this primarily to get less groups. So we have 4 groups, 1, 2, 3, 4, rather than having, I believe 8, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 groups. So that's what we did there. So you just run this. You don't have to do anything special with this. And that's that. I might be in a different mode. I think you might be in a different mode. I'm just gonna keep going. It's fine. Just know that if you're in this mode, it's the same thing. If you're in this mode, okay. So same thing. Just visual and source. Visual looks better than source. And so this is not neither here nor there. Not part of the analysis, but just for you to get a better sense on what was being classified. This code here now allows me to see the table cross tabulation of what was considered as cold drink in terms of this. So shakes and smoothies and beverages. Okay, what's considered as hot drinks, coffee and tea. Okay, something kind of cool. I can't believe, that's cool. So that's that. So now to summary statistics, visualizations, and analysis. So this code is going to allow us to group by the category group. And then we're going to now look at the calories. So what I'm going to do is just do a little bit of a copy and paste game. Copy category group. Okay. All right, so let's just make this wider. I couldn't see the time. So here, category group here, boop. And then we're just going to put calories. For these two, calories. And what this is going to do is give me the mean, the sample standard deviation, the sample mean, the sample standard deviation, and the sample size for each of the categories. So then here we go. We have sample size for all, the means for all, standard deviations for all. If you look closely, the standard deviations are approximately the same. So you take the highest, 275, divided by 120 less than, oh, it's not the same. Sorry, I did my math wrong in my head. 126. So the assumption for equal variance is not met. Okay, so that's something to note. So the trust in our results should be kind of, we should be hesitant on our results. All right, so let's take a note of that. So here, there's a lot of things going on here, but the only thing that you have to change in terms of the visualization is categories. Sorry, it's gonna be calories. This should be calories, and this should be category group. Not just category group. Is it just group? Yeah, it's just group. Group. And then this will let it run. Okay. Ooh. Sorry, delete this theme custom. Sorry. Run. And now you see the plots. So here in this plot, the red dots are the means. Okay. And then the vertical lines, the horizontal lines within these graphs are the medians. Okay. So it's clearly that you can kind of see that meals are having a higher mean compared to the other groups. But is it statistically significant? Is it statistically significant? Okay. If you want to make the labels, you can call this category group. This can be calories. Ideally, I should capitalize these, but it's fine. Calories. Category group. Category group. Again, this is not an R class, so I won't go into so much more detail, but there you go. It looks better. Looks a little better. All right. Now in terms of analysis, finally. So here our response variable is going to be calories. The other variable is going to be category group, and now this should run. So when this runs, I see my degrees of freedom for category group, see which is the between group variability, then the within group variability, 256, sum of squares, mean squares, and then finally my test statistic, 24.6, and then my p-value. So what should we do to our null hypothesis? We should reject it. Okay, we should reject it. We can then further, since we decided to reject the null hypothesis, and I should take 1 second. Let me take 1 second and go backwards. If you look at this graph, yeah, you see a box plot. My apologies, a box plot. But you also see something overlaying this. And what's happening in this overlay, it's a density. Where is most of my data located? So, for example, for cold drinks, they're kind of located towards the middle, near the median. Same thing with regards to hot drinks. Oh, well, same thing with regards to also meals, and then same thing with regards to snacks and extras. But as you can see here, it starts to fade out because of the outliers, okay? So again, the violin plot, that's what they're called. Violin plots allow you to see where most of your data is. Kind of burn over that kind of fast. Okay. So here, in terms of our grouping, we will now put the category group, okay, and then again calories. And the utility behind doing this is just for us to see the means again and then visualize it in a different way. Okay, calories, and then see the means again. Okay. Another way of looking at this is to again do the category groups, but this time we're going to save this information. We're going to save it. Calories. So the first way of looking at it was this way, right, in terms of the data. And then what we're going to now do is take this information of category means and just look at it as a point. So we take this to be categories, and then we take this to be categories. And then now this should be just a point. Gotta move this. Am I missing something? Okay, this should run. This should run. Okay, fine. That's good. And so this is fine and dandy, but I don't like this. And even in my notes, it's not this. What I traditionally would like to see is like a point rather than the bar, because the y-axis doesn't necessarily denote a mean or its actual numerical value. So I'm just going to change this. You can do this in your notes as well. It's not going to change your results, but it just looks better. We kind of have more time to do this, so point, just have points, okay? 529.3, 326.4, 283.9, okay? And so, as you can clearly see, meals is dramatically larger than cold drink, hot drinks, and snacks. But the idea is that we're not accounting for within group variability. So that's why you can clearly see the difference, but we don't know if there's just a within group variability that's dramatically larger. Well, if you look at this, you can kind of see that they're quite similar to one another, right? But again, the within group variability for just meals by itself is just really, really large. And last but not least, the post hoc method. This post hoc method, Tukey's HSD, allows us to figure out which means are different from one another. Let's take a look. So here, this is cold drinks versus hot drinks. So it's hot drinks minus cold drinks. This is the difference. Lower bound, upper bound, zeros included. Our p-value is for us to fail to reject. Meals in cold drinks. There is a difference because zero is not included, right? The p-value is extremely small. Snacks and cold drinks, zeros included. Meals and hot drinks, zeros included. Hot drinks and snacks, zeros included. And then meals and snack and extras, zeros not included. So if you think about it, in terms of what we see here, meals is different from everything else, whereas everything else is pretty much the same. The reason why the within group variability is huge, is because when the within group variability is so large, especially within one group, there could be differences between cold drink and snacks. But since there's so much variability in this group, we can't see that difference. It's not in terms of our data. So that's why that one assumption in terms of equal variance is so important. Thank you.